Buildings make up 90% of Smith's energy footprint, which includes heating, cooling, and electricity. We currently burn natural gas and purchase electricity from the grid. The geothermal project will electrify our heating and cooling loads and provide cooling to most campus housing. Smith broke ground in spring of 2022, and the project is set to wrap up in 2028. Once completed, the geothermal energy system will reduce Smith's carbon emissions by nearly 80%, reduce consumption of water by more than 10%, and improve local air quality. This project is happening in 3 phases. The first including houses and offices north of Elm Street, the second including the quad, and the third including academic buildings and central campus housing. Each phase area has its own well field and energy center. In geothermal heating and cooling, the ground acts as a thermal battery where heat is taken out of the ground in the winter and put back into the ground during the summer. Water is pumped in a closed loop through the wells, which are U-shaped pipes running hundreds of feet into the ground. The water is then transported to the local energy center, where it exchanges heat with a heat pump to either heat or to cool the campus. The heat pump runs on electricity, which provides the additional energy needed to get the water that circulates through our buildings to a comfortable temperature. With the geothermal project, we reduce the amount of energy needed to heat and cool the campus, but increase our electrical load. In order to reduce emissions, Smith needs to stop relying on fossil fuels for our electricity. We're doing this by engaging in renewable power purchase agreements like Farmington Solar, which currently supplies 50% of our electricity. The first district went online in the fall of 2024, and college buildings north of Elm Street are now being heated and cooled by geothermal. A project like this one allows for reimagining the landscape after completion, and this has been an important consideration for the college, who recently completed a landscape master plan intended to guide campus landscape design over the next 20 years. After construction was finished, Davis Meadow, the location of the Elm Street geofield, was restored using climate resilience landscape principles. Planting native species, meadow landscape, and low-mow grass were designs chosen for their positive ecological benefit, promoting healthy pollinator species, increasing biodiversity, decreasing erosion, and sequestering carbon in soil. The Quad District will be similarly restored when construction is completed, and it will be online for the 2025-2026 heating season. The final and largest phase, the Central District, will complete the geothermal project and be completed by 2028. This geothermal bore field will be located under the Smith Athletic Fields. There will be over 200 boreholes to a depth of 800 feet, and our student athletes will compete on top of a state-of-the-art climate solution for the next several decades. The project has also provided many learning opportunities for students. Throughout the process, numerous hands-on student projects have contributed to the geothermal project. Early on in the project, engineering students studied sewer heat exchange as a possible alternative to geothermal. Student involvement has continued throughout the geothermal project. The Amplify Art competition displayed student art that encouraged viewers to reflect on climate change and our collective responses, encouraging dialogue around the geothermal project. Student researchers have also engaged on projects, including Professor Luca Caponia's work on AI to study the efficiency of geothermal, and Professor Judy Cardell's study of thermal storage. Smith, as an entire community, has been dedicated to carbon reduction and the success of the geothermal project. The campus-wide investment speaks to Smith's culture of sustainability and the desire to continue to develop further climate action.